homogeneous equations. Now, till now, we have seen a direct method of solving differential equations, and we have by separating the variables, and then another method we have seen is in which we reduce the equations which can't be directly done, converting it into or reducing it to a variable separable form. So let me just write that down. We have seen equations in which variables are separable. That means x and y, dx and x, dy and y are separated. So this we have done. Then we have seen equation reduced to variable separable form. This also we have seen. Let me just list down what all we are going to do. We are going to look at homogeneous equations. Then we are going to look at equations reduced to homogeneous equations. Then exact equations. Then equations reduced to exact forms. Then linear equations. And finally, equations reduced to linear form. Okay, so this is what we are going to do. Okay, so today we are going to look at homogeneous equations. So a function f of xy is said to be homogeneous of degree n in x and y if f of x comma y is equal to x to the power of n times g of y by x. Okay, so if it is in this form, it is said to be in homogeneous form. So let's see. Let's say we have a differential equation dy by dx is equal to f of x comma y by g of x comma y. Now here f of x comma y and g of x comma y are both homogeneous functions of the same degree in x and y. Here they are called homogeneous differential equations of first order. Okay, so let's see how to reduce it to the variable separable form. Let's say we have dy by dx is equal to f of x comma y by g of x comma y. Now, since these two functions are homogeneous functions, we can write this in this form, right? The only thing is, now since we already have a g function, we have to substitute it with some other letters. So we can write dy by dx is equal to x to the power of n times. For this we have to use a different letter. So phi of y by x divided by x to the power of n times, and let's say for this we will use psi y by x, psi y by x. These two get cancelled and we are left with dy by dx of phi y by x divided by psi y by x. Let's do some substitution. Let y be equal to some multiple of x, right? So let's differentiate it. Dy by dx is equal to v plus x dot dv by dx. Okay, so now let's say dy by dx is equal to v plus x dv by dx. Now dy by dx is nothing but this. So we can say phi y by x by psi y by x. And now let's do one more substitution. X dv by dx is equal to, now y by x is v, so phi v divided by psi v. Now this can be separated, can be solved by separating the variables. Okay, so nothing great, nothing fancy. Let's actually see how it works by solving one or two problems. X minus y dy minus 2x minus y dx is equal to 0. Now this is a differential equation. Now what we want is to figure out the function which when we differentiate we get this. Yes. So let's see. X minus y dy is equal to 2x minus y dx. Dy by dx is equal to 2x minus y by x minus y. So homogeneous equation of degree 1. So let y is equal to vx, dy by dx is equal to v plus x dv by dx. Okay, so here we have dy by dx, here we have dy by dx. So v plus x dv by dx is equal to 2x minus y by x minus y. Let's take v to the other side. Best. dv by dx is equal to 2x minus y is what? Y is vx, right? So vx by x minus vx minus v. Now here x is common to all of them, so let's remove it. So x dv by dx is equal to 2 minus v by 1 minus v minus v. 2 minus v minus v plus v square by 1 minus v. This becomes 2 minus 2v plus v square by 1 minus v. This is x dv by dx. Now let's move it around so that we separate out the variables. So we bring dv 1 minus v divided by 2 minus 2v plus v square is equal to dx by x. So here we have all v, here we have all x. Now let's integrate. Now if you look at this, if we differentiate this, what do we get? The denominator v square minus 2v plus 2. If we differentiate it, we get 2v minus 2, right? But in the numerator we have 1v minus v plus 1, right? So if we get this somehow 2v and change the signs, we'll be able to have it in some standard form. So what we'll do is, first of all, we'll multiply this with minus so that the sign changes. Then we are going to multiply it with 2. So 2 minus 2v dv by 2 minus 2v plus v square. But here in the numerator we have multiplied it with 2. So divide by 2 to equalize it. Okay, is equal to integral of dx by x. Now we have it in standard form. So we can integrate it. Log of 2 minus 2v plus v square is equal to log of x. And whenever you have logs, the integral constant make it also log. So log p. So 1 by 2 log 2 minus 2v plus v square plus log x plus log, or log p, let it be on the other side itself. No, let it come this side, plus log p. Now let's equal to 0. Let's multiply the whole thing, both the sides, by 2. So when we do that, this 1 by 2 disappears. So log of 2 minus 2v plus v square plus 2 log x plus 2 log p equal to 0. Now based on log rules, this 2 can go up, this 2 can go up. So log of 2 minus 2v plus v square plus log x square plus log p square equal to 0. Now again based on log rules, this addition can get converted to multiplication. Okay, so this becomes log of 2 minus 2v plus v square times x square times p square is equal to 0. Now how do I remove log? I do exponentiation on both sides. So this becomes e, this becomes e. So this gets cancelled and anything to the power of 0 is 1. So 2 minus 2v plus v square times x square times p square is equal to 1. Now this is a constant, so let's take it to the other side. 1 is a constant, p square is a constant, so let's rename this as c. So 2 minus 2v plus v square times x square equal to c. Now let's replace v with our original value of v. So 2 minus 2 times y by x plus y by x square, this whole thing multiplied by x square equal to c. Okay, so now 2y by x plus y square by x square times x square equal to c. Now let's add it up. So 2x square minus 2yx plus y square by x square times x square equal to c. So x square gets cancelled and we are left with 2x square minus 2xy plus y square equal to c. So this is the general solution. Now how do we verify it? How do I verify that this is the correct answer? So just differentiate it. 4x minus 2, product rule, 2, let's take it as common. Let's apply the product rule. So x, let's go for dy by dx form itself. So dy by dx plus, now y as it is and this, plus 2y dy by dx equal to 0. Right, now just to keep simplifying it. So 4x minus 2x dy by dx minus 2y plus 2y dy by dx. So 4x minus 2y minus 2x minus 2y dy by dx equal to 0. Here take out 2 common, here take out 2 common. So 2 common out. So this becomes 2x minus y minus here x minus y dy by dx is equal to 0. Now we have reached this stage. The problem is this is supposed to be minus, this is supposed to be positive. Right? In the problem statement we have x minus y dy by dx minus 2x minus y. Now here 2, when we take it to the other side, becomes 0. Now the thing is, this should become minus, this should become plus. So it's just a question of multiplying this entire thing by minus 1. So it becomes x minus y dy by dx minus 2x minus y equal to 0. Yes. Now x minus y dy by dx is equal to 2x minus y. This dx goes there, and let's bring that dx back to this side. 2x minus y dx is equal to 0. This is our problem statement. So we not only got the general solution, but we also verified that we have arrived at the correct solution. Let's solve another problem. Let's say we are given the differential equation y square plus 2xy dx, 2x square plus 3xy dy equal to 0. Okay, let's get this. So dy by dx, we take this to the other side. So y square minus plus 2xy, and the dx comes down here by 2x square plus 3xy. So this is a homogeneous equation. Now what do we do? Take y is equal to vx. dy by dx is equal to v plus x dv by dx. So we have dy by dx, dy by dx. So which means we can write it as v plus x dv by dx is equal to minus y square plus 2xy by 2x square plus 3xy. Now let's take v to the other side. So this also becomes minus v. We don't want to work too much with negatives. So let's make this plus and this as minus. So we end up with minus x dv by dx. Now let's add up this. So y square plus 2xy plus 2x square v plus 3xvy by 2x square plus 3xy. Now let's substitute y with vx. Remember vx? Okay, so v square x square plus 2xvx plus 2x square v plus 3xvx by 2x square plus 3xvx. V square x square plus 2x square v plus 2x square v plus 3x square v square divided by 2x square plus 3x square v. Now all of them contain, all the terms in both numerator and denominator contain x square. So x square, x square, x square, we take it out at common. x square, we take it out common and they both get cancelled. Okay, so v square plus 2v is 4v plus 3v square by 2 plus 3v. Actually, this v square also we can add it. So plus 4v square minus x dv by dx. Okay, here we can take 4 out and we can bring this minus back to this side. Minus 4v plus v square also, which means v also we can take minus 4v times 1 plus v by 2 plus 3v x dv by dx. Now we need to split this, move it around. So what do we do? 2 plus 3v, that means we have to separate out the variables. So 2 plus 3v dv by v times 1 plus v is equal to dx by x. What happened to minus 4? We can say minus 4 is here itself. Now 2 plus 3v by v times 1 plus v. Let's convert it into partial fractions. So a by v plus b by 1 plus v. So this is sidebar kind of thing. So now 2 plus 3v is equal to a times 1 plus v plus bv. Here also LCM becomes v times 1 plus v and it gets cancelled on both the sides. Okay, so now let's say v is equal to minus 1. If we make it as minus 1, what we get is 2 minus 3 is equal to 0 plus b times minus 1. So minus 1 is equal to minus b, or b is equal to 1. Okay, now let's make v equal to 0. If we make v equal to 0, we get 2 plus 0 is equal to a times 1 plus 0 plus 0, which means a is equal to 2. Okay, now that we have converted into partial fractions, let's rewrite this in terms of these partial fractions. So 2 plus 3v has become 2 plus 3v by v times 1 plus v has become 2 by v plus b is 1 by 1 plus v is equal to d. This is dx minus 4 dx by x. dv is there. Okay, so which means we can write it as 2 dv by v plus dv by 1 plus v is equal to minus 4 dx by x. Okay, now we can integrate all of them. So 2 comes out, we are left with 1 by v dv plus nothing, it remains as it is, dv by 1 plus v is equal to minus 4 dx by x. Very straightforward. This is log v plus this is log 1 plus v. This is again log x. And remember, when you have logs, the initial integration constant also you take it as log. Let's say log p. Now let's rearrange them. So this 2 can go up. So log v square plus log 1 plus v plus 4 can go up. So this becomes log x to the power of 4 is equal to log p. Now we can combine this. So we can say log of v square times 1 plus v times x4 is equal to log p. Now we want to get rid of this log, so exponentiate it. So this and this get cancelled, this and this get cancelled. We are left with v squared times 1 plus v times x to the power of 4 is equal to p. Let's substitute v with what? V is equal to y by x. So y square by x square times 1 plus y by x times x4 is equal to p. So x square and this get cancelled, and we are left with x square y square times 1 plus y by x is equal to, let's rename this p to c just to follow the standard convention. So c is equal to p. So this is the solution. Or I think we can go one more step. X square y square x plus y by x equal to c. So one of these x's get cancelled. So x y square x plus y equal to c. Now how do we verify it? Let's verify. So we differentiate this. Alright. So before differentiating, let's simplify it. X square y square plus x y cube is equal to c. Now let's differentiate it. We get x square, leave it as it is. Now y square we need to differentiate. So 2y dy by dx plus, now y square remains as it is. Okay, 2x plus x as it is 3y square plus y cube as it is equal to 0. Okay, so y cube plus y square 2xy square plus 2x square y plus 3xy square dy by dx equal to 0. Now here y common, take it out, y square. So y plus 2x plus, now here x and y are common. So let's take xy common out. So 2x plus 3y dy by dx. Now just so that we can take again something in common, let's take out one of the y's and put it back, and let's take out x and put it back. Yes, so now we have y in common, so let's take out y. We end up with y square plus 2xy plus 2x square plus 3xy dy by dx equal to 0. This y will get cancelled when we take it to the other side, and now we need to rearrange this dx. So what we can do is just take this dx cancel and put it here. In between you can just move it around, left side, right side. You will end up with this. So we have y square plus 2xy dx plus 2x square plus 3xy dy equal to 0. This is our problem statement. So we have solved the differential equation and we have proved that it is correct. We have verified it that it is correct. Okay, I think that's enough. Bye for now.